This is number one. Number two, already we have, Mr. Ahmed, already we know Gauss elimination method and Gauss-Jordan. Okay, what's their advantages on this method? This method works beautifully with consistent, independent systems. Why consistent, independent systems in specific? Because in all consistent independent systems, the value of the determinant matrix doesn't equal to zero. Here, it's a condition to use Cramer that the coefficient matrix determinant should never equal to zero. Because simply if it is equal to zero, you will be dividing with zero. Is it possible? So it is solving just only the consistent independent systems. It is solving the matrices of the coefficient which has an inverse. Because if the coefficient matrix has an inverse, its determinant is not equal to zero. Are you with me? Okay, all of this work together perfectly. So Cramer is very good if you solve 2 by 2. Within maximum 3 by 3, it will work beautifully. You will have no problems with it. But greater than this, it's not going to be easy because you will depend on determinants. Another problem, it solves only the consistent independent system. So it can't solve a consistent independent with infinite number of solutions. It solves only unique solutions. Those are very, very important remarks about Cramer method. Okay, that's another system. If I want to solve it using Cramer, what's gonna be? How to do it? First of all, I will look to the system of equations. Okay, it has to be arranged. Then, I will write the coefficients, which are 3, 1, and 3, negative 2, 3, and negative 2, 1, negative 1, and 2. Here's the first step. That's the coefficient matrix. Okay, all the elements in front, x, y, and z. Check out negative 3, negative 2, and 1. 1, 3, negative 1, 1, 3, negative 1, 3, negative 2, and 2. Here we go. You can evaluate the value of this determinant. If you use it, using Laplace or whatever, it's 11. Doesn't equal to 0. It means I can use Cramer method. Okay, let's use Cramer method. I will get to the value of the first variable, which is x1. That's the x. Here is the coefficient matrix. I will replace the first column by 1, 10, and 2. Am I right? So I will replace this guy by 1, 10, 2. Here we go. 1, 10, 2. Evaluate the nominator. Similarly like for y, variable y, I will replace the second column with 1, 10, and 2. Then I will go for x3, replacing the third column with 1, 10, and 2. And evaluate each one of them using the Laplace or whatever. I have the values of this set of solution or the solution of this system. Now, I want to go with you with determinants and applications. This is the slides of Lisbon. All what you saw, all the previous slides, were quickly how to go through determinants. All the knowledge about 2 by 2, 3 by 3, and properties. How they are explained in Lisbon slides. First of all, we need determinants to answer a question like this. Is there a value that can be determined by entries of a square matrix that tells us if the matrix is invertible or not? What's the value that's going to tell me if the matrix is invertible or not? Evaluate the determinant. If the determinant is equal to 0, it's not going to be invertible. If the determinant is not equal to 0, so this matrix is going to be invertible. This is why we need determinants. Okay, he is explaining to you here, he's explaining here, what's the submatrix? The submatrix is the cofactor, or the matrix that will come by eliminating row and column. Miss Hala, you can answer me for this. Can you tell me what's the submatrix relative to 2 and 3? Which means the cofactor relative to the element 2 and 3. First of all, I will go to the element, which is second row, third column. Second row, third column. I will eliminate them. Then the rest is going to be your matrix, which is simply 1, 2, 2, Here we go, first row, then 0, 1, and 2, then 0, 2, and 1. Okay? And this is an introduction. I'm repeating the previous slides. That's an introduction how to evaluate the sub-matrix or the cofactor. Okay? معايا يا مستر حازم؟ أنت معايا ولا؟ خلي بالك احنا صدقنا كتير. احنا نفسك كده يعني. اوكي. لابلاس ميثود. انت عارفه لابلاس ميثود؟ معايا حلقه؟ انت عارفه يعني ايه لابلاس ميثود؟ لابلاس method, it means to evaluate a value of a determinant by the sign rule and by eliminating any row or any column. That's the generalization. If you have just only a matrix whose n is equal to 1, so that value of the determinant will be the number. We already saw that previously. If I have greater than 1, I will go aij, which is the element, times the sign rule, negative 1 to the power of I plus 1 and so on. That's the sign rule. Times the sub-matrix that you saw previously. And you add them together according to this. This is if you are using rows, or that's if you are using columns. So if I want to evaluate the value of this determinant, it's going to be simple. How to evaluate the value of this determinant using Laplace with first row? Any ideas? So I will go positive 1, and in the row column, 1, 1, 2, and 0. Then minus 2, and in the row column, it's going to be 0, 0, 1, and 0. Then go for the last column, which is going to be positive 1, eliminate row and column, 0, 0, 1, and 2. Here we go. Okay? So eliminating each row, you will get your value for the determinant of A. Same way like if I'm using columns, that's if you're using rows or columns, exactly the same. Here he used the third row elements instead of the first row, and also he showed you how to use the first row. The result is exactly the same. So actually, your question is answered again. You can use any row or any column. As long as you are using the sign rule correctly, you will have the same result. Okay, remarks. If I have a 2 by 2, I can multiply A times B minus B times C, which we already know. We know also rule, multiplying AER times BH and C times BF and G, then minus the other rule. Here we go, that's the substitute. What is the value of this determinant? Quickly. 7 times negative 3 minus negative 2 times 8. Please, careful about the sign conversion. So, it's really simple. So, it's going to be negative 21, then plus 2 times 8, which is going to be a total of negative 5. How to evaluate the value of this determinant? Using Saras rule. Can you give it to me, Mr. Muhammad Tariq? Saras. ماشي حلو؟
ماشي هقول 1
times 5 times 9, then plus 2 times 6 times 7, then plus 4 times 8 times 3, then minus. نشوف الأول بلس بعد كده minus. بعدين minus 3 times 5 times 7, بعدين minus 6 times 8 times 1, بعدين minus 2 times 4 times 9. Okay, I can do that. That's exactly how it is written. معايا يا شباب؟ حضراتكم معايا؟ هتحلها كده. اوكي؟ طبعا طلعت الفاليو بتاعتي بتطلع بسرعه. انت برضو ما فهمتش سؤالك، معناه انك ما فهمتش. انا قلت لك ليه سارس رول ساعات بتبقى كويسه ولابلاس رول ساعات بتبقى كويسه. سارس رول حلوه لو انت بتشتغل محدد 3 في 3. It's really very quickly. اوكي؟ طيب لابلاس رول تشتغل لو انت على اكبر من 3 في 3. لكن لو انت عندك محدد 4 في 4 تضرب 4 باي 4 وعايز تحله باستخدام لابلاس، يبقى انت راجل اعذرني يعني. ليه؟ لان لما يبقى 3 باي 3 وتحله، انا اسف، 4 باي 4 وتحله باي 3 باي لابلاس هتحسب 12 محدد 2 في 2. ها؟ هو عمليه انك تحسبيه بالنمبرز it's gonna be a trivial thing بالنسبه للامتحان. يعني مش يمكن الامتحان يقول لك هيجي 4 باي 4 وهيجي 3 باي 3. ده حاجه تريفيال. لكن انت لو احتجتيه احسبيه باسرع طريقه. ايه اسرع طريقه؟ لو 3 3 يبقى ايه؟ ساينس سريع جدا. طيب لو اكبر من كده اشتغلوا بلس. اوكي؟ واتس اب تو يو في الاول وفي الاخر. والاثنين هيدوا لك سيم ريزلتس. وطبعا مثلا يعني بص يا حبيبي هنا انا اقدر احل ده 4 باي 4 بس I will need your opinion to use which row or which column. بص يا حبيبي لاست رو حلو. ليه لاست رو؟ number of zeros صح؟ Can you give me the sign rule? Positive, negative, positive, negative. So the sign will be negative, positive, negative. So it's a positive line. Yes? Eliminating the row and column. So if I'm evaluating this determinant step by step, I will do it like this. Okay, Miss Hal, it's gonna be 9, the determinant of A. It's gonna be a determinant times eliminated row and column. Can you tell me? 1 0 0, huh?
Yes.
2 4 and 0, huh? 3 5, I'm sorry, 3 5 and 7. Am I right? Continue. Huh? What to use? I'm going to use the plus. Yes, I'm going, just a second. I'm going to use the plus in here instead of Sarah's rule. Okay? Why? Because it's very, very simple. If I لابلاس اللي احنا عاملينه دلوقتي. اوكي؟ سارس ان انا اعمل مالتيبليكيشن للاليمنتس على البرنسبل ده. بس هنا استخدامك للابلاس will be more easier عشان في زيروز كتير. Am I right? So I will use also the first column. اديني first column كده. هيبقى 9 times. هروح على first column. The first number. Using the first column, so I will eliminate the wrong column. So it's going to be 1 times. مليني كده؟
1 times 4
صح؟ That's the determinant of A. طيب, can you continue? صح؟ ليه؟ Evaluating the value of this determinant 4 times 7 minus 5 times 0. which is really simple. يا محمد رغم ان انا قلت لك استخدم 3 سارس ل 3 في 3 لكن الديترمنت ده ما يتفوتش. ليه ما يتفوتش بطريقه بلس؟ لان لو لاحظت على الفيرست كولم هتلاحظ ان في عدد اصفار كتير. فانا لو عملته باستخدام بلس يبقى كده بستخدم ايه؟ ديترمنت واحد يبقى اسرع. طب يا ترى الفاليو هتبقى ذا سيم؟ الفاليو هتبقى ذا سيم. معايا مستر احمد؟ يعني لو انا حبيت احسبه بطريقه سارس it's gonna be 1 times 4 times 7. That's it. The rest of the determinants is not gonna be evaluated. طب تعرفي ليه؟ لأنه upper triangular matrix. Am I right? So either you evaluate it using Laplace أو evaluate it مع طارق باستخدام طريقة Laplace it's gonna be the same. أرجوك ركز معايا. Okay, done. That's the evaluation. It's gonna come up to 252. Also, you have the determinant of the unit matrix is equal to 1. What's the determinant of what's the unit matrix? 1 0 0 1, 1 double 0 0 1 0 double 0 1. All of these determinants, the value is equal to 1. Okay. Let A and B two square matrices. The multiplication of them is going to be the determinant of A times the determinant. Now I will go to some rows, but also relative to the probabilities of determinants. If you make a change in rows, the value of the determinant will change sign. فاكر في matrices when you replace rows, or when you multiply a row by a number and add it on another row, or when you multiply a row by a complete number, those are row operations in matrices. And you will get an equivalent matrix to your main matrix. But in determinants, the value of the determinant will depend on the process that you do. So if I change it 2 rows in a determinant, the sign will change. If I'm multiplying a row in a determinant by a number, the value of the determinant will be multiplied by this number. If I'm multiplying a row by a number and adding the result on another row, the value of the determinant is not going to change. حضراتكم مبهورين بحاجه بره. ايه اللي مبهورين بيه بره؟ في ايه بره؟
واحنا ينفع نقف البركه.
ايه اللي هو الفيلم زي ما هو
ايه؟
انت بتضرب
ايه؟
انت بتضرب
يعني ايه؟ مش فاهم. مش عارف، انا شايفكم بتبصوا بره. انتوا مش عارف بتبصوا على ايه؟ ايه؟ سو ماتش ايه؟ يعني اقف شويه يعني مثلا؟ طيب ممكن تديني بس ايه؟ كمان 5 minutes. بس ايه 5 minutes؟ اوكي؟ بس لازم نخلص الطول. ايه؟ اوكي يبقى تاني احمد عينيك بتتخلع بره.
والله ما
خليك معانا. يبقى value of a determinant تاني once more. It's changing rows or columns. It will change the sign of the determinant. Okay, adding to a multiple of another row is not gonna change the value of the determinant. Adding or product of a constant in a row, it will lead to that this determinant will be multiplied by this number. So actually, the 3 operations that you use in matrices, they have different effects on the value of a determinant. Once more يا حازم، لو replacing the 2 rows الساين بتاعت الديترمنت اللي بيحصل لها تتغير. طيب if you multiply a row by a number الفاليو بتاعت الديترمنت كلها بتتضرب في النمبر ده. طيب if you multiply a row by a number وadd it on another row the value of determinant is not going to change. Those are the 3 main operations in elementary row operations. طبعا اهو this is really very important. That's the first one, the second and the third. بص على الاكزامبل لو سمحت. بص على الاكزامبل. I have a matrix which is 1 2 0. Negative 1, negative 2 4, 2 1 3. I will do some elementary row operations to bring it to an echelon form. Do you remember the echelon form? Okay, so I will go like this. First, I will add the second row, the first row to the second row. So I will add 1 plus negative 1, 2 plus negative 2, 0 plus 4. Okay, that's the first operation. The addition process is not going to change the value of the determinant. So actually, the value of this determinant is exactly the same, the value of this determinant. They are exactly the same. Okay, now I will multiply the first row in negative 2 and add it on the last row. Also, the value of the determinant of this matrix is going to be exactly the same like this one. There is no change. Because you multiply the row in a number and add it on another row. Just wait. Look to the third matrix. Can you see it? Okay, I'm replacing the second row with the third row. If you replace these 2 rows together to get an echelon form, the value of this determinant is going to equal to negative 1, the value of that determinant. Are you with me? So, remark to the operations. How many operations? 3 of them. Replacing rows, change sign. Multiplying row by a number and add on another row is not going to change. Multiplying row by a certain number, it will multiply the value of the determinant in this number. So for here, I have made multiplication and addition, and the replacement. The effects of these 2 operations is nothing. The value of this determinant is exactly like that one. But once you interchange these 2 rows, then the value will be negative. So if we are doing the elementary operation, this is going to be the first operation, that's the second, and that's the third. The effects on the value of this determinant will be nothing, then negative value. Of course, evaluating the value of this determinant is really very simple. Evaluating value of that determinant 1 times negative 3 times 4, which is 12. And you have a change of sign, so that actually the exact value of this determinant is 12. معايا؟ This one, E1, that's E2, that's E3. Both E1 and E2 is not going to change the value of the determinant. This is the one that's going to change the sign. So if you evaluate this value, it's going to be negative 12 times the negative, it's going to be 12. حد يقدر يقول لي انا عملت القرف ده ليه؟ لأن حضرتك لما تيجي تحسب الديترمنت اللي في الأول يعني تحسبه باستخدام طريقة لابلاس باستخدام طريقة ساينس. لكن أول ما أنت حطيت الديترمنت ده على الإشلون فورم أصبحت الفاليو بتاعته كده 1 في نيجاتيف 3 في نيجاتيف 4 في ثانية تحسبها صح؟ فدي معلومة. المعلومة الثانية والمهمة إن أنا عارف البروبابيلتيز بتاعت الديترمنتس فالفاليو بتاعت الديترمنت ده بس بغير الساين بتاعه. يبقى إذا بحسب وأغير الإشارة. اتفضل. بإيه؟
واحد في
نيجاتيف 4 بنيجاتيف 12
ضربنا في نيجاتيف
عشان عملت الريسمنت بس. اوكي؟ اهو انا دول غايه في الاهميه. اوريدي انت عارفهم كلهم، انا عديت عليهم كلهم بس تاني وانس مور. الديترمنت بتاع الترانسبوز زي الديترمنت الماتريكس. اي واحد. الديترمنت لو مش بيساوي زيرو يبقى الماتريكس انفيرتبل. اوكي؟ والفاليو بتاعت الديترمنت واحد على الفاليو بتاع الديترمنت بتاع الايه. الديترمنت بتاع كيف ايه دي مهمه جدا جدا جدا. لو انا ضربت ماتريكس في نمبر بيتضرب في اول فاليوز هيساوي الكي تو ذا باور اوف ان يعني عدد الروز مضروب في الديترمنت اوف A. انا عملت اللي عليا وخلاص انت اللي هتشيل. هنا if A has 2 equal rows or 2 equal columns the determinant is equal to 0. If you have a one row the value بتاع الديترمنت is 0. If B is obtained from A by exchanging rows the value A اللي هيحصل لها. طيب if C is obtained من ده عن طريق a multiple of another يعني C is obtained from A by adding to a row a multiple of another the value will be the same لأنك بتضرب row في رقم وتجمعه row. لو بصيت على آخر واحدة D is obtained from A by multiplying a row by a scalar يبقى الفاليو بتاعت الديترمنت بتضرب في سكالر. probabilities دي غاية في الأهمية. final system probabilities. هنا بيقول لك what is the determinant of the inverse of this matrix؟ لو انا عايزك يا حلا عايزك تحسبي لي الفاليو بتاع الديترمنت بتاع الانفرس بتاع this matrix تقدر؟ تاني عايزك تجيب الديترمنت بتاع الانفرس بتاع this matrix تعملي ايه؟ ده ما تزعلش مني ما تزعلش مني اكتر. امال اعمل ايه؟ احسبه ازاي؟ هجيب الديترمنت ده واقلبه ماشي؟ اهي بص اهي. فيبقى اول حركه احسب الديترمنت بتاع الماتريكس دي باي طريقه. عايز تستخدمه بلس عايز تستخدمه بطريقه المتسارس زي ما انت عايز. انا حسبت الديترمنت بكام؟ ده ديترمنت الاي ماتريكس يبقى الانفرس بكام على الاي دي يبقى 1 over 2 يبقى الديترمنت بتاع a minus 1 يساوي 1 over 2. طبعا مش هروح اجيب الانفرس الاول وبعدين بحسب الانفرس بتاعه ماشي. طبعا علشان اكد لك على المعلومه انا حسبته اهو طبعا ده في ثانيه. طبعا انت دخلت تجيب الانفرس بتاع الماتريكس دي انت كده مسكت الست عريان طبعا. لان طبعا ده معناه ان حضرتك هتشد دوت لاين وتكتب 1 0 0 0 1 0 0 0 1 تبدا تشتغل بالبروسيس او هتستخدم كو فاكتور ميثود هوريها لك كمان شويه. طيب ماشي؟ اوكي. ده ماينس 1 حسبت الفاليو بتاعتي. طبعا ده كرامر رول احنا لسه معديين عليها دلوقتي نفس اللي احنا قلناه بحسب الفاليو اوف ذا كوفيشنت ماتريكس ديترمنت بعدين بشتغل على كل اهو ده الديترمنت بتاع الكوفيشنت ماتريكس بعدين I will replace every column from these columns by the result which is 2 1 and 4 which is very very simple. So Z is going to equal to the coefficient matrix replacing the last row by 2 1 4. خلي بالك ممكن في الامتحان ما يقولكش استخدم كرامر to solve the system. لا ممكن يقول لك find the value of the variable z يعني هات القيمه بتاعت الفاريبل اسمه ايه؟ z يبقى انا كل اللي عليا ان انا اعمله اجيب الكوفيشنت ماتريكس زد ده ام مقارن لاست كولم اريبليس الاليمنتس بتاعت اللاست كولم هيطلع تاني زي ما عملنا تاني معايا؟ هنا انا ما حسبتش اكس وواي وزد انا حسبت زد دايركت اوكي؟ اوكي فيري جود طبعا في عندك exercises on determinants هنا بيقول لك evaluate the value of each of these determinants خلاص انت تعرف تحسبهم كل واحد فيهم خلاص يعني ده you will use the first row هنا I can use one of them substitute or plus to make a difference هنا how to evaluate the value of this determinant which row are you going to use or which column ده الثird row صح؟ طيب if you look to this one okay first column or first row صح؟ طبعا the value of this one just look at it it's a general matrix so you can evaluate it as you like and this one too I can simplify my life if I added a multiple of a number to each and echelon form and evaluate using the main method this is also one of the very nice problems he's asking you giving you a 4x4 determinant and asking you what's the determinant of this matrix as a function of A. How to solve this? يقول لك evaluate the value of this determinant as a function in alpha. As a function in alpha. Okay. Use any method, either Laplace or Sar's rule. Okay? Or Laplace and Sar's either because you have 4x4. So I will go for solving this matrix by using the first row, so it's going to be alpha, eliminate the wrong column, this is going to be the determinant, then negative 2, eliminate the wrong column, this is going to be the matrix, and so on. Then I will simplify my life, evaluating each one of them. Of course, remark the huge number of zeros that exist in each one of them. So it's going to be an easier task for you to evaluate. And that's the value, which is 2 alpha minus 1. Of course, in the exams, he can give you this question, and he will give you 4 alternatives and you will choose the right option. Am I right? Exactly the same. Okay, done. For the second part, he's asking you to put alpha is equal to 1. If you put alpha is equal to 1. So I can use the last result. All I have to do is to replace alpha by 1. So it's going to be 2 minus 2, which is going to be negative 2. So replacing the alpha was equal to 1. Then use B200 is 1. And what is the value of x3? What's the value of x3? You can do it using grammar. Okay, here we go. That's the determinant. Using the alpha is equal to 1, I will make a substitution. So it's going to be, this is the determinant that I want to evaluate. I'm talking about system X is equal to B. So that's the result of the augmented matrix. I can continue as you you wish. I can continue this matrix by evaluating the value of x3. This is x3. So all I have to do is to evaluate the value of the major determinant, which is going to be negative 2. And then replacing the element of this row, this column, by 2001. Evaluate the value and divide them on each other. Or use Gauss elimination method to continue. Or whatever you want. Okay? This problem also is very nice. If the system is inconsistent, that's the answer. I've already sent you the results for the solution. How to evaluate this system if A, B, and C. That's a very nice problem. I want you to look at. It's really solved and I've already sent it to you. So I will just skip it. The rest of these problems, I will look at them later, but just to go through them one by one in order to reach your information. This is the last part of, or that's the part of the determinants that I want to go with you. Within the next week, inshallah, I will try to prepare for another session on Python for the part of the if statement and the final part. I didn't finish our lecture today. What's the time now? 3:30?
Yes.
3:30 يعني. Okay, you have 10 minutes. You have 10 minutes. Okay, you have 10 minutes just to move around, to buy something, to go to the restroom or whatever, then come back to me. I will go, okay, for a very important part is how to bring an inverse of a matrix. Then I will go through the eigenvalue or eigenvector. So you have 10 minutes. Just move around. Okay, thank you.